Hello, this is question 13 on your June 2019 paper 1 from AQA. It's simple to be 7 marks, you see. So we have to show that this curve has one stationary point. To find stationary points, we are going to differentiate and make that equal to 0, remember? So I do, it's a quotient, a fraction, so I'm going to use the quotient rule, which is I derivate this one and multiply by this one. So I have 3e to the power of 3x minus 5 times by the denominator, then minus derivative of the denominator, which is 2x, times by the numerator, and divided by the denominator square. This formula, the quotient rule, is in the formula booklet. Sorry, what do I have? The formula booklet. Here. Yeah, it's the only one between the quotient and the chain rule and the product rule that is in the formula booklet. Yeah? And I'm going to just try to simplify things. So you have like two terms here. Both of them have x. So I'm going to cancel 1x here, 1x here, and 1x here. So I can divide everything by x. And I have this, and then I'm going to factorize because I have e to the power of 3x minus 5 in one term and in the other one. So I can write this as e to the power of 3x minus 5, brackets, I have 3x in this side, and in the other term I have minus 2 only. Minus 2, all divided by x to the power of 3. This derivative must be 0 for the stationary points, which means that the numerator must be 0. And I think you are going to see very quickly why we have only one answer. This factor cannot be 0. So e to the power of something is never 0. Remember, we have an asymptote when we represent e to the power of something x. Yeah. So e to the power of 3x minus 5 is always different than 0. So my only solution is 3x minus 2 equals 0, which means x is 2/3, is the only solution. Yeah, and that's it. It's very quick, it's not difficult, and it's 7 marks. Yeah, that's all.